In this video, we shall find the sufficient statistics for estimating mu, that is the mean, given the PDF from a normal distribution. Solution. For more on this topic, you need to subscribe to this channel. The factorization theorem is used in solving sufficient statistics. And the factorization theorem states that for any PDF to be a sufficient statistics, that PDF will be able to be factored out into two components. What are the components? We have f of x into mu this time is equal to phi mu into, we have u, x1, x2, xn into mu, because it depends on mu. For the first one, multiplied by x1, x2 to xn. So, for a statistics to be sufficient, it must be able to be factored out into these two components. This is the first component, and this is the second component. And now we are given of x to be equal to 1 all over sigma square root of 2 pi exponential negative 1 all over 2 into x minus mu all over sigma all squared. So this is the distribution given. Now, what do we do next? The first thing to do is to take the likelihood function of this. Taking the likelihood function, it means we have f into x, the mean and sigma to be equal to, this likelihood function means the product sum of the same function and sigma, which is equal to the product sum of the given function, which is 1 all over sigma square root of 2 pi exponential negative 1 all over 2 into x minus mu all over sigma all squared. Now, we can write this out properly. We can write it out properly. We can write it to be as I running from 1 to n, 1 all over sigma square root of 2 pi exponential negative x minus mu raised to the power of 2 all over 2 sigma squared. Because this will square this and this will square this. These two will multiply this. So we can write it out like this. So how do we take the product sum? It will now be equal to, our function will now be equal to, taking the product sum, the first one will be 1 all over sigma square root of 2 pi to the power of 1 minus x1 minus mu squared all over 2 sigma squared, multiplied by the second one, 1 all over sigma square root of 2 pi raised to the power of 2 exponential negative x2 minus mu raised to the power of 2 all over 2 sigma squared, multiplied by, it continues like that, multiplied by the final one to get 1 all over sigma square root of 2 pi raised to the power of n exponential xi minus mu squared all over 2 sigma squared. So if we multiply it, This is what we'll get. It then means that we can write this out properly. Then it then means our function will be equal to, after taking the product sum, we'll get something like this. 1 all over sigma square root of 2 pi raised to the power of n exponential negative, if you sum this, we'll get, that means we'll sum this, and it continues to this point. We get summation of, as I running from 1 to n, xi minus mu raised to the power of 2 all over 2 sigma squared. So this is what we get. This is what we get. So how do we factor this out? How do we factor this out? We still need to expand further. So we move over to this other side of the board. For more on this topic, you need to subscribe to this channel. Now, we should note that this, from quadratic equation, from quadratic equation, we have that before, that x I minus mu squared will give us xi squared minus 2 mu xi plus mu squared. It then means that if we have summation sign here, summation of xi minus mu squared is equal to summation of xi squared as I running from 1 to n minus 2 mu summation of as I running from 1 to n xi plus mu squared. So this is what we'll get. So, but if you sum a constant, you still get that constant, or you get n times that constant. Now we impute the whole of this into what we get here. We can write our function. Our function can be written as x mu sigma to be equal to 1 all over sigma square root of 2 pi raised to the power of n exponential, nothing has changed, exponential, we bring out whatever we have here, we put it inside there. So negative summation of xi squared minus 2 mu summation of xi plus mu squared all over 2 sigma, all over 2 sigma squared. Now because of this sign, we have to open this bracket to write it out properly. So we have f to be equal to 1 all over sigma square root of 2 pi raised to the power of n exponential negative summation of xi squared plus 2 mu summation of xi minus mu squared. all over 2 sigma squared. We can also rewrite this further. We move over to this other side of the board to write out this properly. For more on this topic, you need to subscribe to this channel. So it then means that our function can be written as 1 all over sigma square root of 2 pi raised to the power of n exponential. Now we say summation of x I squared as I running from 1 to n all over 2 sigma squared, the negative sign here, plus 2 mu summation of xi as I running from 1 to n all over 2 sigma squared minus mu squared all over 2 sigma squared. So this is what we get. Now we should note that exponential a plus b plus c is equal to exponential a multiplied by b multiplied by c. You should know this. Meaning these two will cancel these two. Now we can rewrite this properly from what we have written here. F will now be mu sigma to be equal to 1 all over sigma square root of 2 pi raised to the power of n exponential from what we have stated here. Now, which one depends on mu? Which one depends on mu and which one depends on x alone? Now we have exponential negative summation of xi squared as I running from 1 to n all over 2 sigma squared multiplied by exponential. We'll now bring this out to give us mu sigma xi minus mu squared. Let me write it out properly because of space. We have multiplied by exponential. We are now left with mu summation of xi all over sigma squared minus mu squared all over 2 sigma squared. So we can bring this over to this side. So our f of x mu sigma will be equal to, this can come over here, exponential mu summation of xi all over sigma squared minus mu squared all over 2 sigma squared multiplied by 1 all over For more on this topic, you need to subscribe to this channel. So we have f of x mu sigma to be equal to what we have here. Exponential mu summation of xi all over sigma squared minus mu squared all over 2 sigma squared multiplied by 1 all over sigma square root of 2 pi raised to the power of n exponential negative summation of xi squared all over 2 sigma squared. So this is what we get. Of course, we can still take the LCM of this, but it doesn't matter. So we have here as one of the components, and we'll have this other side as the other components. So this component gives 5 mu into x1, x2 to xn as it depends on mu, while this component gives h x1, x2 to xn. Or better still, we can still write it as 5 mu can still write it as this. Nothing has changed. So we are asked to find the sufficient statistics for mu. It then means that we can now say for sure that our mean is a sufficient statistics for estimating mu. So this is how we can estimate mu if we are given the normal distribution. Yes, we have to compare it with the factorization theorem, what it states about sufficient statistics. We have succeeded in putting these things into 2 different components. Of course, these components depend on mu. And if you watch here, you won't find any of this mu, any of this sign here. So this component depends only on this. For more on this topic, we need to subscribe to this channel.